This is the final lesson in Level 2. Tomorrow we are going to finish it in class, but you're going to start creating your notes today. Please make sure you complete the notes as instructed in this video and bring the notes to class tomorrow so that we can conduct the rest of the lesson. The essential question we're going to be looking at is, how do I conduct a successful math fight? And why are we doing this? Because to win an argument, you must be able to give evidence that proves your claim or disproves your opponent's claim. Let's talk about what some of those words mean, okay? So if you look at the first example, the claim is that everyone in the classroom is wearing red, right? And if that's the claim that someone is making, either that statement is true and you're going to prove that it's true, or that statement is false and you're going to disprove it. And you're going to give a counterexample. Take a moment and write down the definition of prove on example 1 here in your notes, and write down the definition of disprove. Now that you've written down the definitions of prove and disprove, let's look at how we get from our claim to any statement to win an argument. You can't just say, I'm right, and you're wrong, and I've won the argument. That doesn't work in math. You have to give evidence. So if you look here, when you start with a claim, something that someone says, and you're like, I can either prove it or I can disprove it. You have two pathways here, right? Prove or disprove, but both paths require evidence. You have to evaluate the evidence and decide if it's true or false. So make sure you write these words here for both paths, right? Evidence, because both are required. Evidence is required for either path. So what is evidence? Evidence is something that proves that a statement is true, right? Like if you look around the classroom and every single person is wearing red, then yeah, absolutely, that is a true statement. But if you look around that classroom and you can find one person that this statement is not true for, then you have found evidence that the statement is false and you can disprove it. So you're in the hub right now and everything's pretty quiet, so just look around. Don't distract anyone, but look around. Is everyone wearing red? If every single person in the room is wearing red, then you have evidence that that statement is true. But if you look around, and from what you can see where you're sitting without getting up, if you can see anyone who is not wearing red, that person is what we call a counterexample. A counterexample is that one example, it doesn't have to be more than one, just one person who's not wearing red counters that statement and says, nope, it's not true, because not everyone is wearing red. So look around right now. Is everyone wearing red? If so, I want you to take a moment and pause the video and write up here the evidence that you see in the classroom that everyone is wearing red. If it's not true, I want you to write the evidence of what you see in the classroom down here. All right, you should be on the back side of your notes now. If you notice, we skipped from example 1 to example 3. So make sure you're on the back side of your notes. We're not going to go through this entire example, but I want to talk about some of the strategies that you can use. And before you finish this video, I want you to have some evidence written down, ideas of how you might prove or disprove the statement. And then we'll figure it out tomorrow in class. So here's the statement, and this time it's a mathematical statement. So now it's not just a who's wearing what fight, it's a math fight, right? Is the statement true or is it false? So here's the statement. If x is positive, so that means x can't be negative, can't be 0, has to be positive. If x is positive, then negative x over 5 is sometimes positive. So that means x can be any positive number. And if x is positive, the claim is that if we plug a number in here for x, a positive number, that we will get a positive value. Which then this right here is, remember, the opposite of x over 5. So let's think about this. How could we give evidence either to prove this statement or to disprove? Because this isn't as easy as just looking around the room and saying, oh, no, there's somebody who's not wearing red, so that statement's false. Right? But if it is false, you can still come up with a counterexample. So how do you do that with math? Well, you look at the x. If x is positive. So over here off to the side on your notes, list some positive numbers. Start with 1. 1, 2, 3, 4, 5, right? List some positive numbers. Then take those numbers and start plugging them in to this expression. So let's say from my list of positive numbers that I wrote down, let's just pick the first one, x equals 1. All right, I'm going to take that and plug it into that expression. So here's my statement, the opposite of x divided by 5. Well, if I let x equal 1, the opposite of x is negative 1. So this is the fraction negative 1/5. Negative 1/5 is negative, obviously. So is this evidence to prove or disprove our statement? Well, let's take a look. If x is positive, so if x is 1, then the opposite of x over 5 is sometimes positive. Well, if x is 1, then the answer is negative. So no, that's not true. But it doesn't say it has to be positive all the time. It just says sometimes it has to be positive, right? So just sometimes it has to be. So let's try another number. Let's try 2. All right, and then the opposite of x over 5 is the opposite of 2 over 5. The opposite of 2 is negative 2. And it's still negative. Now we're going to finish this problem tomorrow. But make sure you at least have this part here written down that we've been talking about. And think about this. Predict what will happen if you keep trying positive numbers. Will it continue to be a negative number? In which case, if it always is going to be negative, then you've disproved the statement. Because this is saying if x is positive, right, positive 1, positive 2, 3, 4, 5, then I can plug it into this expression and get a positive number. If I keep getting negative numbers, then no, I can give evidence that that's false. But if I can find a positive number that I can plug in here and get positive, then I can prove it's true. So think about it. We're going to answer the rest of this question, really come up with a convincing argument to prove or disprove it tomorrow using some of this evidence. The last thing I want you to do today is just to acquaint yourself with some vocabulary for this question here. You might recognize it. This question is actually from the pretest that we took for level 2. And most of you took one look at that and went, Miss Shenton, what in the world is this asking me? And I told you, don't worry, it's a pretest. We're going to go over it. Because I knew we were going to come back to this and we were going to work on constructing arguments. But there is a lot of vocabulary in this question. We're not going to go over how to prove or disprove this statement in the video, but what I want you to do right now is read it and let's familiarize ourselves with the vocabulary. So the statement says, for any non-zero integer x, the quantity, the opposite of x over 5, represents a negative rational number. There's a lot of math words in that sentence. So since you got to be prepared for your math fight tomorrow, let's at least go over the vocabulary, okay? Non-zero. So on your notes, please write down for non-zero that non-zero number is any number but 0. Integer, we learned the definition of integer in Unit 1. And integers are positive and negative whole numbers, including 0. Make sure you write down that definition. Quantity. Quantity just means like everything that follows the word quantity in the expression, right, is what's being talked about as a group, right? The expression in parentheses. So the quantity is the opposite of what's in parentheses here. In this case, it's the opposite of x over 5, but the definition of the word quantity is any expression or the expression in parentheses. And finally, rational. A rational number, we learned that at the beginning of Unit 2. A rational number is any number that can be written as a fraction. So make sure that you understand this vocabulary. Tomorrow, this is going to be our math fight, and I want you to try this right now. We're going to do this tomorrow. During our math fight tomorrow, you are going to give evidence, and you are going to construct an argument to prove or disprove this example. Hang on to these notes. We're going to pull them out and finish them tomorrow.